All right, so the two formulas we need to know for arithmetic are the nth term, which is a sub n equals a1 plus d times n minus 1, and the partial sum. I would say for this chapter, you want to keep like a running reference sheet. Obviously, you can't use it on your test, but it will help you review at the end. N over 2 times first plus last. All right, so number 1 says determine whether or not the sequence is arithmetic. If it is, find the common difference. So I'm doing 3 minus 5, negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. Negative 3 minus a negative 1, negative 2. Because they are all the same number, it is arithmetic. And D is a negative 2. So again, the sign on that is important. If it's going up, it should be positive. If it's going down, it should be negative. Two, write the first 5 terms of the arithmetic sequence. So it's giving me A1 and D. You have 2 choices here. Find the nth term equation. So if it said find the nth term, then I would have to set up my equation. A sub n would equal 8 plus 3 times n minus 1. 8 plus 3n minus 3, so 5 plus 3n. That's if it asks for the formula. And then I could plug in 1, 2, 3, 4, 5 to get my 5 terms. That's one option. If it doesn't ask for the formula, like this one did not ask for the formula, then I can simply just go, okay, 8's my first one, add 3 to it, that's 11, add 3 to it, it's 14, add 3 to it, it's 17, add 3 to it, it's 20.
That's like recursive.
This would be recursive and arithmetic, so not all recursives are arithmetic. All arithmetic are recursive, though. So 3 says use the formula or information from number 2 to write the formula for the arithmetic sequence. So we already did it. That's this one. A sub n would be 5 plus 3n. And then find the sum of the first 25 terms of the sequence. So I need the sum, which is n over 2 times first plus last. What would be n? 25. My first term, A1, we already have it as 8, but if I didn't have it there, I would plug in 1 here, and I'd get 8. Okay, so then I need the last, right? So I don't have the last yet. How could I find the last? Plug in 25. So into this, 3 times 25 plus 5 is 5 plus 75, which is 80. And then I get 12.5 times 88, which is 1,100. All right, 4 says find the sum of the first 50 positive multiples of 5. So it's a sum. If it's a multiple of 5, it's going up by 5 each time, so it's arithmetic, which means we can use this formula. N over 2 times first plus last. What's the number of terms if it's 50 positive multiples? The first 50 positive multiples of 5. How many numbers are in there? There's 50. There's 50 numbers in the first 50 positive multiples, yes? If you're saying 25 because you already cut it in half, that's fine. But if it's positive, it's all those numbers, right? It's all 50 of them, yeah? So it's 50. It does. It says positive, which is all of them.
I understood
Even, right, okay. Then what's the first positive multiple of 5? 5. What would be the 50th, and how would you get there? 250. Just multiply them out, okay? 50 times, there are 50 of them, so it'd be 50 times 5. That's the last. If there were 60, I'd multiply times 60. If there were 70, I'd multiply times 70. If it was multiples of 3, I'd be multiplying by 3. So then I get 25 times 255, which is 6,375. All right, and then 5 says find the partial sum. 2n minus 3 is arithmetic. You'd be subtracting 3 halves each time. Like, although there's a number at the front, it's still arithmetic, okay? So I do n over 2 times first plus last. How many terms are there if it starts at 1 and ends at 10? 10. The first term, I would plug in 1. So 2 times 1 minus 3, 2 minus 3, which is negative 1. The last number I would plug in 10. 2 times 10 minus 3, 20 minus 3, which is 17. So then this is 5 times 16, or 80. Now with 10 terms, it wouldn't be impossible, but you could plug in 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, and add them all together, okay? It won't be that small of a term on a quiz or a test, so you definitely need to know that formula. Questions? All right, so 8-3 is a geometric sequence and series. So we started with general sequence and series. We narrowed it down to arithmetic, which is adding the same term each time. Now we're getting into geometric, which means we multiply the same number each time. God bless you. So a sequence is geometric when the ratios of the consecutive numbers are the same. So if I take A2 and divide it by A1 and take A3 and divide it by A2 and A4 and divide it by A3, I get the same term. So like if I'm multiplying by 2 each time, or if I'm multiplying by a half each time, those would be geometric. This time, the variable we use for it is R, and it's called the common ratio instead of the common difference. And it cannot be 0 because then every term in the series is 0. So you can either multiply by a whole number or you can multiply by a fraction. All right, so example 1 says determine whether or not the sequence is geometric. So I'm doing second over first, third over second, fourth over third, whichever ones I've got. So I'm going to do 12 divided by 3, and that's 4. And then I'm going to do 48 divided by 12, and that's 4. And then I'm going to do 192 over 48, and that is also 4. Because they are all the same, the answer is yes. If it had asked for it, my R would be 4. Nope, it's just 4. Yep. God bless you. Sorry? You always divide to figure out what R is. Yes. B is 1 to a half to a third to a fourth. So if I did 1/2 divided by 1, it'd be the same thing as 1/2 times 1, and that's a half. If I did 1/3 divided by 1/2, that's the same thing as 1/3 times 2, and that's 2/3. Right there, these are not equal, so this is not geometric. See it in a second. This one says, write the first 5 terms of the geometric sequence. So pay attention to directions, right? This is going to eventually get grouped together with arithmetic. So you have to pay attention to it. If it's arithmetic, I'd be adding that number each time. If it's geometric, I'm multiplying by this number each time. So I get 1 times a half, and that's a half. Then I get a half times a half, and that's a fourth. And then I get a fourth times a half, and that's an eighth. And I get an eighth times a half, and that's a 16th. So my 5 terms start with 1. 1, 1/2, 1/4, 1/8, 1/16.
Is this like recursive? I can think of both.
Yep. That's only because they give you the first one.
Like you're not putting in 2, 3, 4, 5.
You can. I'm going to teach you how to find the equation, and then you could. This is just easier.
You're just going to multiply the top.
Yep. That is A1 times R raised to the n minus 1. Yep. So that's the formula you are using to find any term of a geometric sequence. So this says, write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term of a sequence as a function of n. So this is recursive, right? And it's also geometric, it's telling you that. So I'm going to take the first term, which is 9, and then I go to the second one. I take A2 would be 2 times the one that comes before it, which is 9, and that's 18. A3 is 2 times the one that comes before it, which is 18, and that's 36. A4 is 2 times the one that comes before it, which is 36, and that's 72. A5 is 2 times the one that comes before it, which is 72, and that's 144. So that's the first thing, right? The first 5 terms of the geometric sequence. 9, 18, 36, 72, 144. The k plus 1 is this next term. The k is the previous term that you're using. So k plus 1 is technically 2 here, right? So then k is a 1. That's what we used here. Now we got to find the r. So what happens each time, right? 18 divided by 9, 36 divided by 18, 72 is times 2. So my r is 2. That's the second part. Excuse me. And then the last part, so that's this part. And then the last part says, write the nth term of a sequence as a function of n. So a sub n equals a1 times r to the n minus 1. A sub n would equal a1, which is 9, times r, which is 2, raised to the n minus 1.
And that's how we would do it.
Yep.
Wait, how did you get ours? Oh, because you
Yep. If it then asks for like the 12th term, then you'd plug in 12.
How do we do that on a 4-bit calculator?
You would have to raise the power. So they won't be too high, but you'll raise it to a power and then you'll multiply.
You can raise the powers.
No, but you could do 2 times 2 times 2 times 2. Yeah. Is n, no, a sub 1 is 9.
Wait, how do you don't continue
No, it's just one of the equation. If it asks for like the 10th term, then I'd make n 10. But it's just asking for the equation and to stop there. All right, this one says find the formula for the nth term of the geometric sequence, then find the indicated term of the sequence. So it's saying find the formula first, then find the 7th term. So for my formula, I need a sub n equals a1 r to the n minus 1. I need to know a1. What's a1? 3. I need to know r. What's r? 12, because 36 divided by 3 is 12, and 432 divided by 36 is 12. So r is 12 raised to the n minus 1. Now it wants the 7th term. So I'm going to do a7. 3 times 12 to the 7 minus 1. 3 times 12 to the 6th. 12 to the 6th. Times 3 is 8,957,952. I mean, 12 is a big base, so that should make sense that it jumps. I could have also said this is A1, this is A2, this is A3. Multiply by the 12, and that's A4. Multiply by the 12, that's A5. Multiply by the 12, that's A6. Multiply by the 12, that's A7. So you could do it either way. Because it asked for the formula this way, I would say it's easier just to plug it into the formula. Questions on that one? All right, this one says find the indicated term of the geometric sequence. Now this time I've got A1 and I've got A4, and it eventually wants the 10th term. So if you are doing something other than paying attention, stop and focus. Because if you understand this, it's super easy. If you don't understand it, it gets super confusing. You don't have 2 consecutive numbers here, right? We have A1 and we have A4. So if you think about our formula, if I do AN equals A1 times R to the N minus 1, and I wanted to find consecutive numbers. Let's say I start with A1 and I want to find A2. A2 would be here. A1 would still be there. And R to the, what would be the exponent? 2 minus 1. So this would be A2 equals A1 R to the first. You with me so far? If I wanted to find A sub 3, it would be A1 R 3 minus 1, which would be A3 equals A1 R to the second. If I wanted to find A4, it would be A4 A1 R to the 4 minus 1. A4 equals A1 R3. We don't know, but we're establishing a relationship. So what do you notice about the relationship between the base on the left and the two numbers on the right? Base on the left, two numbers on the right. Base on the left, two numbers on the right.
R minus 1 equals 3, 3 minus 1 equals 2.
So you can either take the exponent and subtract the base from it, or add the base to it and get the left side, right? Or just realize that whatever number's on the left, the number here plus here has to equal that. So if I wanted to find A3, I have to have A1 and then R squared. If I want to find A4, I have to have A1 and R to the third. So the numbers here, the base on the A plus the exponent on the R is going to equal the N, whatever I'm trying to find. Does this make sense? So if you look at what's given, like ignore all this stuff and look at what's given to us this time, I have A1 and I have what? A4. I put the bigger one on the left, so A4 goes on the left. A1 is where I start. What does the exponent have to be on the R? 3. So now I know A4 is a half. I know A1 is negative 4. I don't know R. So that's what I'm going to solve for. So if I wanted to get to R to the third by itself, what do? Divide both sides by negative 4. So divide or multiply by negative 1/4, and I get negative 1/8 equals R to the third. And then what? Cube root. What's the cube root of negative 1/8? Negative 1/2. Now I have R. So I can say AN equals A1 times R to the n minus 1, and I can use that to find any term in the sequence. So this is complicated because we didn't get consecutive terms, and this is how you'll always do it. Bigger number on the left, so A to the bigger base on the left equals A1 R to the difference, so bigger number minus 1, which would be the base there. It doesn't even have to be A1 though. I could go from A2 to A5 using the same process. A5 would go on the left, A2 would be the first term, and R would have to be raised to the third. You're going to see that in a minute. So now if I want to find the 10th term, I'm going to do A10 equals negative 4 times negative 1/2 to the 10 minus 1, negative 4, negative 1/2, 9, raised to the 9th power. So this is where it will get trickier on a the 4-function calculator. You want to because you want to keep these exact. You want to separate out your numerator and your denominator. So this would be negative 4, negative 1 to the 9th power stays negative 1. And then 2 times 2 times 2 times 2 times 2, so 2 to the 9th is 512. It's going to stay negative because that's an odd exponent.
Wait, R was negative 1/2.
Yeah, once we solved for the equation. And then 512 divided by 4 is 128. So this is 1 over 128. And it's positive because they were both negative. Yeah.
What would be like given an equation that's not geometric sequence that we have to find like
All of this is geometric. Yeah.
So we'll always be able to find R.
Yeah. In order to have an R, it has to be geometric. Yeah. There is no R without it being geometric. All right. So this is that next one. Look at our bases. We don't have consecutive ones. We don't even have to have A1. What we have is A2 and A5. So in order to find R, I'm going to plug this in. So AN equals A1 normally, R to the n minus 1. But if I don't have consecutive, I do A to the bigger one equals A to the smaller one times R to the big minus small. You do this enough time and you won't have to remember that, but that's that's the process. So which base is bigger, A sub 2 or A sub 5? So the A5 is going on the left. It's going to equal A2 times R. What's the exponent on the R have to be? 3. So if you don't have consecutive integers, you have to use it this way. Or consecutive terms, not even integers. The bigger base goes on the left, the smaller base goes on the right, and then the R gets raised to the power. That's the difference between those two. So A5 is 2/3. A2 is negative 18 times R to the third. Then I have to divide both sides by negative 18 or multiply by negative 1 over 18. 2 goes into 18 9 times, and I get negative 1 over 27 equals R to the third. I cube root both sides, and R is negative 1/3. So if I want the equation, I could plug it back in, but I only need to get to the 6th term, and I have the 5th. So what could I do? Just multiply 2/3 times negative 1/3, and I get negative 2/9.
Let's say it wasn't that close and you needed the equation.
Then you can literally use either terms. If I wanted to go from A5 to A6, I could say A6 equals A5 R to the first. If I wanted to use A2 and A6, I would do A6 equals A2 times R to the fourth. You could get any terms you want once you figure out what R is.
Like you wouldn't need to find A1.
If it said the nth term and you had to find A1, I would have to take negative 18 and divide it by a negative 1/3 to get A1. But you don't have to do that.
So you use the same, like the bigger, smaller.
Yep, bigger, smaller, difference. Yep.
How would you rate it if you wanted to find the first term?
So that's what she was just asking. I said you'd have to then take negative 18 because this is A2. So I could do A2 equals A1 R to the first. A2 this time I have. A1 is what I don't know. R is negative 1/3. So I'd have to multiply both sides by negative 3. And I'd get A1 is 54. And then I'd get AN equals 54 R to the n minus 1. I'm not R, sorry. We know what R is. 54 negative 1/3 to the n minus 1. Yep.
So even though it's a negative under the square root or cube root, it doesn't matter. You can still.
Because it's a cube root. If it was a square root, you couldn't do it. So if it's a square root, that won't happen because that wouldn't give you you couldn't get an answer. Yeah. Yeah, you can go any direction you want as long as you put the bigger base on the left and then the smaller one on the right and R raised to the difference. Yep. All right, so this is the last part. There's 2 summations. The funny thing is the very last thing we do today is probably the easiest thing you do in all of the summation stuff. This is finding a partial sum or summation. It won't say the words partial sum. It would say sum of the either infinite geometric sequence or the finite geometric sequence. So the sum of the finite means it's fixed, right? It's going to have a stopping point. We use this equation, A1 times 1 minus R to the n over 1 minus R. A1 should still be the first term if the number is 1 on the bottom. R is still what's being raised to the power. N is still going to be the number of terms. So if the number on the bottom is 1, N is your answer. If the number on the bottom is not 1, then it's the top minus the bottom plus 1. So same as the partial. That doesn't change. When you're trying to figure out the number of terms in a sequence and you have a summation, top minus bottom plus 1 is always the way to do it. If it's 1, you don't need to. Just grab the top number. But if it's not 1, then you need to do that. So A1, now we're on what formula? 4, right? So a sub n, the sum for arithmetic, a sub n, and this is finite sum for geometric. All right, so it says find the sum. I know this is geometric because there's a base being raised to a power. That's what makes it geometric, okay? So I need, obviously, I do a1 times 1 minus r to the n over 1 minus r. I need a1. If the bottom number is 1 here, and this exponent is I minus 1, or whatever the variable is minus 1, then this is a1. If the bottom number here is 1, and the exponent over here is that minus 1, then the number that's not raised to the power is a1. That's your standard form. If it's anything other than that, then you take the bottom number and you plug it in and you get your first term. So even if I'd done that here, if I plug that in here, I'd get 32, 1/4, 1 minus 1, 32, 1/4 to the 0. What's anything raised to the 0 power? 1, 32 times 1, and this is 32. So you can do it the same way we did the partial sum. Plug in the bottom when it's the first term, plug in the top when it's the last term. That works the same. So I know that that's a1, 32. 1 minus, r is the thing that's being raised to the power. So r is 1/4. What is n this time? 6. If the bottom number is 1, the top number is n. And this goes over 1 minus 1/4. With me so far? Yeah? All right, this is where it gets annoying and tedious, right? We have to keep these exact. So there's no plugging into a calculator and getting an answer for this. That's a decimal. This is kept exact, so we break it into its parts. 32 stays on the front, but then I have to do 1 minus 1 to the 6th, which stays as 1, and then 4 to the 6th, which in a 4 function will be 4 times 4 times 4 times 4 times 4. Oops, I just wrote 44. 4 to the 6th, which would be 4,096 over 1 minus 1/4. Now I've got a complex fraction. I can't keep the fraction within the fraction. So I'm going to work together on the top, work together on the bottom, keep, change, flip. So I have to change the top to have the same denominator. This is going to be 4,096 over 4,096. The good news is that is always 1. So you just have to change it to be the denominator of the other one over that denominator again. And then the bottom, this is going to be 4 over 4. That will also always be 1, so you can change it easily. So now I have 32, 4,096 minus 1, so 4,095 over 4,096 divided by 3/4. Now I keep, change, flip it. And this will always simplify. So 4,095 divided by 3 is 1,365. And 4,096 divided by 4 is 1,024. Now I've got 32 times 1,365 over 1,024. And now I got to see if 32 goes into 1,024. It's 32 times, and my answer is 1,365 over 32. So these numbers are going to be ugly, but that is the same process every time. And you won't give me a decimal there. You will keep these exact, simplified but exact. So I'm going to walk through the process just one more time. We have to find A1, which is the thing that's not being raised to the power if the bottom number is 1. If not, we have to plug in the bottom number. That's your 32, right? Then we did 1 minus r. That's the thing that's being raised to the power. To the n, top minus bottom plus 1, which in this case is 6, over 1 minus r. Raise this to the power here. Find the least common denominator in both the numerator and the denominator. Keep change, flip, and then simplify as much as you can. Still good. I know it's a lot today because we had to blend in yesterday's, but okay. All right, this one says use summation notation to write the sum. This is where it gets tricky because there's not like here, this is how you do this, right? You have to figure out, is this, first of all, is it geometric or is it arithmetic? Because it's going to have one of those patterns. So from 7 to 14 and 14 to 28, and then there's all those spaces in between. I don't know what's happening there, okay? If it is, which we're going to use geometric because that's what we're in, 14 divided by 7 is what? 2. 28 divided by 14 is 2. So I know at least r is 2.
How did you know it was in?
Well, because we're in the geometric section, we're going to do geometric.
If we didn't.
You wouldn't be able to figure out the spaces in between there. You probably could do this using arithmetic too, but we're going to do it geometric. I'd have to work it out. Yeah. Okay, so what else do you know? I know the first term is 7. What else do you know? I know the last term is 896. What I don't know is how many jumps there are in between there. So think about how we could rework that equation. We could put an, which is what we don't know, on the left, but we know that that's the higher base. A1 on the right, and r to the n minus 1, because that's the difference between what we're finding and the base on the other side. That's your normal equation. So if 896 goes on the left and 7's on the right, and r is 2 to the n minus 1, can I solve for n? How? How am I going to get 2 to the, I can't separate 2 to the n minus 1, right? So how do I get that by itself? Divide both sides by 7. That's 128.
Bring up the base to kind of whatever the exponent.
How do you do that? Oh, you're plug and check. Okay, there's another way to do it. It's been like, I don't know, 2 chapters, but it's somewhere in there. You can ln both sides of this equation, or you can log both sides of this equation. ln. You can bump to the front. ln of 128 equals n minus 1 times ln of 2. Divide, because I'm not going to give you a calculator to do this, but n minus 1 would equal ln of 128 divided by ln of 2, and you get 7.
Where did you get
In order to get rid of an exponent, okay, that would be if you had the calculator. If you didn't have the calculator, sort of what Daniel's doing, I would change the base. So instead of trying to figure out what to raise 2 to get like the other way around, I'm going to change this base, right? If it's geometric, these are always going to be ones that can be changed of base.
Wait, where did you get the 7?
From here. Like 7 is your first term.
No, I know, but
Yeah, so I divided both sides by 7. Oh, from here, I actually plugged this into the calculator.
Oh.
Okay, without a calculator, though, I'd have to take the 128 equals 2 to the n minus 1 and change the base. So 128 is 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. How many 2's is that? 2, 3, 4, 5, 6, 7. 2 to the 7th equals 2 to the n minus 1. And then 7 equals n minus 1, and n is 8. Yeah.
Why did you break it down n minus 1?
For which one?
Like after you
Give me a color. After I ln'd over here, the ln of 2's, I divided both sides by the ln of 2.
How did n minus
You bump it to the front. That's if you ln, but you're not going to have a calculator to ln. So I would say that is a way to do it, but you're not going to have a calculator do it, which means you have to do the change of base side. But don't let that confuse you because you won't do it. So that's just the number of terms. I'm not done yet, right? I still have to find the sum. So the sum of a geometric sequence is A1 times 1 minus r to the n over 1 minus r. A1 is 7. R is 2. N is 8. 1 minus r. So 7, 1 minus 2 to the 8th would be 256. 7, negative 255 over negative 1. So 7 times 255. And it's 1,785. So again, this left side would only be if you had a calculator, and you won't. A scientific calculator, and you won't. So just make sure you know how to change the base. You know how to set it up. So we plug in the information we have. A-N on the left. A1 is 7. R is 2. And then it's raised to the n minus 1. We divided both sides by 7 to get to this point. And then you will be able to change the base because it has to. It has to be able to be a power of the other one. So then you'll figure out, what do I have to raise to 2 to get to 128? Change the base and then set your exponents equal to each other like this. That gives you the n, and then you have all the pieces of information you need for your geometric sum. Questions on that one? So it sounds ridiculous because it's the sum of an infinite sequence. How do you add something that never ends, right? It actually works. So because it gets so small on the tail end that eventually it gets to the point that it's so close to 0, it's insignificant, is basically what happens. So the way that you can find an infinite geometric sequence, okay, first of all, infinite, you will see the infinity symbol, and that's how you'll know it's infinite. So the top number won't be a number anymore. It's going to have the infinity symbol. Looks like this. And the formula is the most basic of all the formulas. A1 over 1 minus r. This only works if r is a fraction that is less than 1. So you cannot do this if r is bigger than 1, okay? We absolute value it because it doesn't matter if it's positive or it's negative, but it cannot be bigger than 1, and it cannot be less than negative 1. Has to be a fraction, not improper. And that's why you can do it. Because as we continue to raise, if you think about it, as you raise a fraction to the highest, if you keep raising 1/2 and raise it again and raise it again and raise it again, it keeps getting so small that eventually it trails off. It's so teeny tiny that it doesn't make an impact on your sum. That's why you can use this, okay? You cannot do this with something like r is 2. That number would become so much bigger that it's always going to affect my sum, okay? So I do A1, so the first term, over 1 minus r. Now notice that the summation looks different on this one. This is how else you could see it. Now the base is 0 and the exponent is just I. It would be the same as if this was 1 and this was I minus 1. It's not going to trick you, okay? You can always find the first term by taking the number on the bottom and plugging it in if you're unsure. That's always your A1. If this is 0, this will just be the variable, and then you can still take the A1. If this is 1, this would be I minus 1, and then you can still take the A1. If you're unsure, the first term is your A1. You can always take the bottom number and plug it in, okay? So if it throws you off. So this says, find the sum of the infinite geometric series, if possible. If not, explain why. So the if not means that r is bigger than 1. Or r is less than negative 1, okay? Remember, it has to be a fraction in between those two. Actually, bigger than or equal to, because it can't be 1 because then it doesn't change. But, all right, so this would be 1 minus A1 over r. A1 minus 1 over r. Let's try that again. A1 minus No, I did that right. Sorry.
Wait, can you go back up? I didn't get the top.
Hang on. Let me write it first. A1 over 1 minus R. Say that again. Go back to this. So that would be if it's not possible. Yeah, if it said y and you said it's not possible, your reason is it's bigger than 1, it's smaller than 1, anything like that. All right, so A1 is the one that's not being raised to the number, or to the power, so that's 5. Over 1 minus, my R is a negative 1/2, so this stays negative 1/2. I'd get 5 over 1 minus a negative 1/2 becomes 1 plus 1/2. This would be 2 over 2, so this is 3/2. And then we keep change, flip it. And I'd get 10 over 3, and it stays just like that. So most calculators cannot do these because you can't put an infinity symbol in the top. There's like a workaround, like you can just make that top number super, super big, but this is just as easy, and you won't have a graphing utility to do that. A graphing utility can find the sum of a finite geometric sequence, just not this one. So that's 5 formulas. AN for arithmetic, sum of arithmetic, the partial sum. AN for geometric, finite geometric, and infinite geometric. So those 5 you need to know for the quiz.
The quiz is only
It's
1, 2, 3.
correct, yeah.